Okay, physics answers to some questions. I'm going to do a video on answers to questions, and then I'll do a video on the next section. Some people had some problems with this, and I think maybe the language was more the problem than anything else. I'm not sure. Someone said I had a problem with all of them except 4. Some of them I said I had a problem with all of them. So I'm going to do 7 for sure, because I know historically as I teach that 7 is usually a problem. I'm going to do maybe 1, 3, and 7 or something like that. Okay. Number 1 says find the gravitational force between the Earth and the Sun. And it says see Appendix B for physical physical constants and data. But you may not need that. You might need it, but you may not. So I'm trying to find the force of gravity between the Earth and the Sun. And so the formula is force of gravity is G m1 times m2 over r squared. Someone had a generic question about r. I'm hopefully going to answer that as we go through. So the r depends on what 2 masses are you talking about. Okay, in this case we are talking about mass 1 being Earth and mass 2 being the Sun. So Earth and the Sun, okay? And we're talking about the gravitational force between the 2 of them, okay? So if I'm looking for the mass of the Earth, you can look in Appendix B. It will have it there. Or you can look at the sheet that I gave you, which said the Earth has a mass of 5.98 times 10 to the 24th. And every year I rememorize that number because we use it a whole lot. So it goes away after a little while, but now that I see it again, it's probably going to be stuck there for a little bit. Mass 2 is the mass of the Sun. And again, mass of the Sun, 1.99 times 10 to the 30th. The other thing I need is a radius. Radius is the distance between the 2 of them. So if I look at this, think about what that is. The Earth orbits the Sun. So this is the orbital radius. In the first column on that sheet that I gave you, it just says radius. And so if you look at Earth and you look at radius, what they're giving you is from the center of the Earth to the edge of the Earth, what is that radius? But that's not what we're looking for. We're looking for the radius between the 2 of them. So we're actually looking for the orbital radius, which for Earth is 1.49 times 10 to the 11th meters. So my radius is 1.49 times 10 to the 11th meters. So G is a constant, 6.67 times 10 to the negative 11th, times M1, that would be the Earth, 5.98 times 10 to the 24th, times mass of the Sun, and I'm running out of space, so 1.99 times 10 to the 30th, over r squared, which would be 1.49 times 10 to the 11th squared. Now, if that's what you have, if those are the numbers you have, and you still got your answer wrong, here's what that tells me. You're not running your calculator correctly. That's what that tells me. All right? Please remember order of operations. Your calculator only knows what you tell it. I'm sorry, I'm trying to find Harriet. I set her somewhere. There she is. your calculator only knows what you tell it. And if you tell it to your calculator incorrectly, it's going to give you the wrong answer. So exponents first. So I'm actually going to deal with this squared thing first. So I'm going to put a bracket and I'm going to put 1.49 times 10 to the negative, no, not negative, times 10 to the 11th, whoops, times 10 to the 11th. And I'm going to close that bracket and I'm going to go squared. And that's actually going to give me 2.2201 times 10 to the 22nd. On the top, I'm going to have 6.67 times 10 to the negative 11th. I'm going to multiply and I'm going to put brackets around this. 5.98 times 10 to the 24th times, and I'm going to put brackets around this. 1.99 times 10 to the 30th. And I end up with 7.9, and it keeps going, 3, 7, and it keeps going, times 10 to the 44th. I'm going to divide that, and again, I'm going to put this in brackets, 2.2201 times 10 to the 22nd, and I get, and I can only have 3 significant figures, so 3.58 times 10 to the 22nd newtons, and that is the answer that I got before. Again, if you had all these exact same numbers that I did, but you got your answer wrong, that's a calculator issue. That is not a I screwed up the formula issue, all right? That is a how did I communicate with my calculator? Order of operations means you do this exponent first. Figure out what that is. I multiplied everything across the top and divided by that answer. I use, listen, default brackets. Like even if you don't think you need brackets, put brackets anyway. Better to have too many than too few. So just be sure that you can communicate well with your calculator. You really need to be able to do that. And I would love to be able to say, everybody just do this, but I can't because every calculator is just ever so slightly different, screwing up everything. So I can't sit in a video and go, everybody do this. I can't because it just doesn't work that way. All right. I don't know. I'm going to pick another one. We're going to pick number 3. No reason, just because. Number 3 says, how far apart? That's an R, right? That's R is how far apart are the two masses. So that's an R. That's what I'm looking for this time. How far apart would you have to place 2 7-kilogram bowling balls? So mass 1 is 7, mass 2 also 7. How far apart would you have to put them so that the force of gravity between them would have to be 1.25 times 10 to the negative 4th? So again, force of gravity is G m1 times m2 over r squared. So force of gravity, they actually give me this time. G is 6.67 times 10 to the negative 11th. M1 is 7, M2 also 7. I'm looking for r squared. So I'd multiply both sides by r squared, so I would have 1.25 times 10, oops, that should be negative 4th, to the negative 4th, r squared equals 6.67 times 10 to the negative 11th times 7 times 7. So r squared would be 6.67 times 10 to the negative 11th times 7 times 7, all divided by 1.25 times 10 to the negative 4th. But I want r, not r squared, so I have to take the square root of both sides. Again, from here on, it's a calculator question, right? It's a, can you put this in your calculator correctly? So I would do 6.67 times 10 to the negative 11th times 7 times 7. I would hit equals at that point. So I get, what is that whole top? Then I would put divided by 1.25 times 10 to the negative 4th, and I would actually put brackets around it. You may not need to, but I would, just to be sure. And then I would square root that whole answer. I got 5.1 times 10 to the negative 3rd meters, which is 0.51 centimeters apart. And I actually put that is not possible, because it said, would it be possible to place them at this distance? Here's why, okay? Your orbital radius, remember these are bowling balls, okay? And we're assuming big ball bowling, so it's got the 3 holes in the top, right? 3 holes in the top. It says that your radius between the two, and that means the distance from the center of one bowling ball to the center of the other bowling ball, should be 0.5 centimeter. You can't do that because the bowling balls are bigger than 0.5 centimeter wide. Like, the radius alone is more than 0.51 centimeters. So it's actually not possible to place these bowling balls the correct distance apart so that the force of gravity would be that. It's actually impossible to do. You can't do it because of what the radius between the two of them would have to be. And remember, radius means the center of one object to the center of the other object. Okay? Glad I picked that one so that I could explain that. And then I think I will do number 7. So again, to answer the question, how do I know what R is? Sometimes you're trying to find R, but other times, again, when we were talking about the mass of the Earth to the Sun, that would be the orbital radius. If you're just talking about 2 objects, so just to talk real quickly about, say, number 4, it says they are 5.30 times 10 to the negative 11th meters apart. Well, that would be your R. So they give it to you in the question if it's not dealing with like planets and the sun, because that's in your table. Number 7 is the one that, historically speaking, with other classes, I've had to go over. So for number 7, it says the radius of the planet Uranus is 4.3 times the radius of Earth. So the radius of Uranus is 4.3 times the radius of Earth. Okay. The mass of Uranus is 14.7 times the mass of Earth. So the mass of the planet is 14.7 times the mass of Earth. So I don't really know what those values are. And it says, how does the gravitational force on the surface of Uranus compare to that of Earth's surface? Okay? So they're not asking you what is it, they're asking you the same type of thing. The radius is 4.3 times bigger than Earth. The mass is 14.7 times bigger than Earth. So how many times as large is the force of gravity on that planet? So really what we're doing is we are comparing the force of gravity on Uranus to the force of gravity on Earth. And we know that the formula for force of gravity is G m1 m2 over r squared. And for this force would also be G times m1 times m2 over r squared. So ignoring this for a second, okay, because this is equal to this. These two things are making the same statement. This is talking about Uranus, and this is talking about Earth, okay? I'm actually dividing these two things, right? I'm actually dividing these two things. If I'm dividing these two things, first off, to figure out the force of gravity, actually, I'm gonna expand this out. I'm gonna go G mu m2 over r squared divided by G me m2 over r squared. So I'm just writing it horizontally instead of vertically. The reason I'm doing that is because I can see it better now, and I keep, switch, flip when I'm dividing fractions, right? So I keep this one the same. I switch my sign and I flip this over. So I have a G on top here and a G on top here. Those actually on the bottom there. So those actually cancel. These R's can't cancel though, because this is where we're talking about Uranus. So that's the mass. This is the radius from that planet to the sun, because force of gravity is the result of the sun. So that's the radius, the orbital radius of the planet to the sun. This R is the radius of our planet, Earth, to the sun, which is going to be significantly different, okay? It's going to be different. And I don't even care what it is. I'm just looking for the sake of looking. So, yeah, Uranus is further away than the sun is. I'm not good with planets. So these R's can't cancel because one has got a U and one has got an E subscript. So they don't cancel. But what about this M2? I've got an M2 on the top here and an M2 on the bottom. What is that M2 representing? Well, when we're multiplying the two masses together to figure out the force of gravity, it's the mass of the planet times what it's being attracted to, which is the sun. In both cases, it's the sun. So yeah, those actually can cancel. So now my question looks a little easier, because what I have is I have mu over ru squared times, okay, times re squared over me. Now, the problem is I've got way too many different variables going on here, but Ru is equal to 4.3 Re. I figured that out here because the radius of Uranus is equal to 4.3 times the radius of the Earth. So I can actually replace this. I can actually replace this with 4.3 Re, Re squared and the mass is 14.7 times the mass of the Earth, so I can replace this with 14.7 times mass of the Earth. The reason why I would do that is because now I have an Re squared on the bottom and an Re squared on the top. Those will actually cancel. And Me and Me will actually cancel. And I actually have 14.7 divided by, now remember both of these were squared, so it would be divided by 4.3 squared. And if you do that, you get 0.8 FE. Because remember, it was, Uranus was on top and E was on the bottom. So it's 0.8 the times whatever the force of gravity on Earth is. It's 0.8. In other words, it's less than 1. I'm not going to give you a question like this on a test, so don't worry too much about it. But it all just has to do with the ratios. So if you don't get number 7, it's okay. Don't worry too much about it. I'm not going to ask you one like that on the test. But it is good to be able to compare. All right? So that was sort of the challenge question of that section. All right. I'm going to stop that there.